Once the ATLAS instrument transmits 6 laser beams to Earth, the telescope receives the photons that bounce back from Earth.
Hey there, I'm Tyler Evans, an Opto-Mechanical Engineer on the ISAT-2 mission, working on the ATLAS instrument. So for the receiver subsystem, the biggest component is the telescope, which is 0.8 meters in diameter, which is about 31.5 inches in diameter for the primary dish. So the primary dish is the reflective surface that you see, which has curvature to it. And the way that it works is light goes into the primary dish and is collected by this big dish, and it gets focused up into the secondary mirror, which is at the end of this tower. And then the secondary mirror shines the light and focuses it down through that tube to the center, to the back of the telescope where the detectors are. And this telescope is made out of beryllium, which is kind of a unique material that has a high strength to weight ratio. So this whole telescope only weighs 50 pounds. Now, to know which way the telescope is pointing, there's 4 green lasers that are coming out of the telescope. So if you look into the main dish, you can see the 4 TAMS spots, the Telescope Alignment Monitoring System. And those go out of the telescope and get picked off by this periscope. And the receiver periscope picks up the light from the telescope and bends it back into the LRS. The LRS is the Laser Reference System camera. So that's really the brains behind the closed loop control system that looks at those 4 spots and knows, as it tracks those 4 spots, how the telescope is pointing. So now that you've seen the front of the receiver subsystem where the light goes in, I'll take you around back to be able to show you the fibers on the other end where the light actually goes into the detectors. You can see the 6 black fibers that are plugged into the back of the telescope. Those actually go out to the detector where they're able to analyze those photons that came back from Earth and compare them to the photons that were sent out to check the stopwatch and see what the distance actually was of that ice that they just measured. So this is the stellar side of that LRS camera, and this lens here looks out into space and it looks at the stars to see how the satellite is pointed. So based on what constellations it's seen and how the stars' angles are coming into this lens, it knows how the spacecraft is pointed relative to Earth. Once the photons are filtered through the telescope and into the fibers, they go into the optical filter assemblies, or the etalons. These filters have a really small bandwidth, around 532 nanometers. So that's really specific to only have the photons that we sent out come back. This is really important because otherwise the sun would dominate the signal. So the photons now go to the PMT detectors, which are the photomultiplier tubes, where the photons are converted to electricity and timed.